So, welcome everyone, and welcome to this class. This is Circular Dynamics lecture number 9. As far as we remember, I remember in the previous class we had completed circular dynamics for horizontal circular motion that is taking place on a horizontal plane, and we had discussed almost all types of cases. The last one being the turning of vehicles on circular roads. And as we saw that the vehicles can turn using two things. Either they can turn using friction only, and in that case we saw that the maximum velocity that is possible for turning is Vmax is root over mu s into rg. This is the maximum velocity that is possible for a car or a truck or a bike or a cycle to turn on a circular track only using friction. Then we saw that there is one more thing that we can do to turn the vehicle on a circular road, and that is to bank the road, make the road at an angle. This angle theta, which I'm marking right now with green, is known as the angle of banking. If you remember, angle of banking, and this is normally 3 to 5 degrees, 7 degrees at most. And if this is banking, then the maximum velocity that is possible for us to have is root over rg tan theta. The simple way of remembering this is instead of mu, you have tan theta. One more thing that I want to add here in this class, which I incidentally forgot, is instead of sometimes giving you this angle theta, which is the angle of banking, when the question is given in a different way, what they give you is sometimes they give you the height of the road. The road is lifted by a height h. I hope you can see this. The road is lifted by a height h, which I am showing right now. And the length of the road is given, the length of the road is given as L. So instead of giving you the value of tan theta straight away, they give you the height the road is raised and the length of the road, L, something of this nature. Now, if it is given like this, you can easily calculate the value of tan theta. Can anyone tell me what will be the value of tan theta? Instead, theta is not given, and the value of h, the height to which the road is raised, is given, and the length of the road is given. So I can calculate tan theta from here. What will be the value of tan theta? Can anyone tell me? What will be the value of tan theta? If theta is not given, that the angle of banking is 5 degrees or 3 degrees, it is not given to you. The only thing that is given to you is the height h and the length L. You can easily calculate the value of tan theta as h by L. Tan theta will be equal to h by L. Oops, wrong color. Why this color did not change? Tan theta is h by L, and you can use the value of tan theta in this equation. Am I clear? Can I have some raise hand that we understand this? All of us understand this? That sometimes tan theta, theta is not given straight away, it is given in this way. Also, at many times, instead of giving you this L, they can give you, and I will mark it with a different color, they can give you this L. The length of the road will be given in this fashion. The length of the road is L here, like this. Now remember, no matter this horizontal length is given or this hypotenuse length is given, this angle theta is very, very small. Normally it is very small, 3 degrees, 4 degrees, 5 degrees. So even if this L is given, the green L, or the orange gel is given, if the orange gel is given to you, if orange gel is given to you, you can find out the value of sine theta. If orange gel is given to you, you can find out the value of sine theta. Now sine theta in this case will be equal to h by L, perpendicular divided by hypotenuse. But remember, this theta is very small. This theta is very small. And you might have heard about this. If the angle is very small, your sine theta will be approximately equal to your tan theta, which will be approximately equal to your theta if theta is calculated in radians. I hope all of you know this. Since you're bio students, you might not have an idea, so you please note it down. In any case, whether horizontal L is given or the slanted L is given, if horizontal L is given, you can straight away get tan theta from h by L. If this slanted or hypotenuse wala L, length of the road is given, you can calculate the value of sine theta, but normally this theta is going to be very, very small unless and until the theta is very large. If theta is very large, then you first find the value of h, then you know the value of L, then you get the value of base, and then you can calculate the value of sine theta or cos theta. For example, if theta is 30 degrees, then tan of 30 degrees will become 1 by root 3. But tan of 30 is 1 by root 3, but sine of 30 is only half. So the difference is more. 1 by root 3 is not equal to 1 by 2. But for smaller angles, sine theta and tan theta approximately have the very, very same values, which is also same as the value of the angle theta. So they are all three are equal. Will you remember this? For small angles, I'll write it here as a note, big red. For small thetas, remember the small theta ka meaning hai, this theta must be in radians. For small theta in radians, sine theta is approximately equal to tan theta, is approximately equal to the value of theta, and this is the condition that we have used here. I will wait for a minute for you to note this additional information in today's class. For the banking of roads, we also read in the last class how a motorcyclist, instead of using banking of roads, can bend himself and turn the vehicle. In that case also, if the angle is given from the vertical theta, the velocity with which he can turn, the maximum velocity with which he can turn is again the same velocity root over rg tan theta. I'll give you a minute to note this additional information. I'll be back after a minute. Well, I hope everyone has noted this down. So, in that case, we shall move on to today's class. And what are we going to do in today's class? Well, horizontal circular motion is over. So now we'll move on to the last topic of this chapter, which includes circular dynamics as well as work, power, and energy. And we move on to the last topic, and that last topic is known as motion in vertical circle. Motion in vertical circle. Now, what do you mean by motion in a vertical circle? It is plain simple. Instead of things moving like this, where making a diagram of horizontal circle was a bit difficult. Every time everything was going inside and coming outside. Now things are going to happen like this in this plane. So previously, if I just give you an example, motion was happening here on this plane. Tuck, 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 tuck. Now the motion will be happening on this plane. that you can directly draw on your sheet, where this becomes your vertical side. Motion in a vertical circle. Now again, this motion in a vertical circle can be discussed under certain headings, and well, these headings may get confusing at times, and I will try my best for them not to sound very confusing, but again, you have to be patient and try to understand as you go. Maybe it will take 2 or 3 classes for me to finish this up. Be patient and try to understand what I'm meaning to say here. I might not be doing the complete analysis because that is not required for you guys. What we'll be doing is understanding the different cases and trying to remember the important point on those cases. The first case that we are going to do, case number 1, is motion on outer surface of a body, of a motion on outer surface of a body. So this body, which I'm going to draw now, shall I draw it using this? Okay, should draw it using this. I hope this will make sense. Oops, they didn't get converted. This is better then. Okay, this one. Okay, this is how it is. Okay. Motion on outer surface of a body. Now, what is going to happen here? You will have this outer surface of a body. Now, this body, as you can see over here, looks circular. It's a 3-dimensional body. It could be a cylinder. It could be a sphere. It could be a ring. It could be a disc. So it could be a 3-dimensional body. It could be a 2-dimensional body, or it could be a simple wire, which is turned in the form of a circle. Now, what will happen in this case, that the body will be, it is going to move on the outer surface, so it cannot move. It can also move from the lower part, but most of the cases, what will happen, you will have a body kept here of mass m. The mass of the body would be given to you. There would be a body of mass m kept on the top of the circle. It's not a circle. It can be a cylinder. It can be a sphere. It can be a disc. It can be a wire. And the radius of this would be given as r. Now, this body of mass m would be at rest at this point. Most of the cases, it would be at rest, the most general case. Now, what is going to happen here is we will just give a very slight push to this body. We will give a very slight push to this body. Now, what will happen if we give a very slight push to this body of mass m? Remember, it's in a vertical circle, and that is why I've drawn it like this. What will happen if you give a very small push to this body? Tell me the answer. What happens if we give a very small push to this body? Anyone? What happens if you give a very small push to this body? Very small, gentle push to this body. What happens to this body, which is kept at rest on the top of this cylinder or sphere or disc or wire? What will happen? Well, the obvious thing is this body will fall. this body will fall, and when it falls on the outer surface, it would be performing circular motion. Yes or no? Do we understand this? Can I have raise hand that you understand? If I give a small push to this body will start to fall. This body will move on the outer surface of the body, the sphere or the cylinder on which it is kept, and it will be performing circular motion. Yes or no? Do we have an understanding of this? Do we understand this? Class, online class, offline class? Can I have some raised hand that we understand this? Online class, yes, we do have raised hand. What about the offline class? Do we understand this? It's very difficult to interact in such a way that I don't see these guys, don't get any reaction from these guys. It's not a good way of conducting a class. Anyone can give me a thumbs up that we understand this from the offline class? No one? Anyways, so this block is going to move and it will follow circular motion. Now what will happen at some point in time, this block will reach some point which makes an angle theta. If I say that the starting point is A, this point, let us call it as B. So it will reach this point B. Now most of the questions are concentrated on these 2 points. So now the body will be here. Now the body will be here. Now what all things can be asked to you at this point? In most of the cases, you would be given the value of this theta that I have marked in yellow. You would be given the value of this block M, the mass of this block M, and you would be given the radius of this circular body, cylinder, sphere, whatever it is, as R. Apart from this, what you always know is your G. G is your acceleration due to gravity. G is your acceleration due to gravity. Now, these things will be given to you. G is known, R, theta, and M. And whatever questions come to you would be given or would be asked in terms of these unknown quantities. For example, at the topmost point, the body is at rest. But here, this body would have gained some velocity. So they might ask you what is the velocity at this point V. It would obviously gain some velocity. What is the velocity at this point? This is the first question that they can ask. So the first question that they can ask is what is the value of V, the velocity. And this is the most prominent question that is asked in such a case. Here, the most important question that is asked is the value of the velocity V in terms of the angle theta. Now I can make a lot of questions here. For example, they can also ask you what is the value of this normal reaction N. If I draw the free body diagram at this point B, weight mg would be downwards. Normal reaction N would be like this. Oh, I might have drawn it. It might look a bit different. So what I do is the normal reaction should be along the normal direction. So it should be like this. Both the lines should match. So normal reaction would be like this. Now they can ask you the value of this normal reaction. That is the second question. Then they can also ask you a very typical question which might not come in NEET ever. What is their tangential acceleration of this body? what is the centripetal acceleration of this body? Now, these two questions, in fact, all these three questions, this one, normal reaction, tangential acceleration, and centripetal acceleration, they are not very likely to come. The most likely question, if this type of question comes ever, is this first one, where you find out the velocity of this block, or you tell us the velocity of this block v at this point. Now, how do we do this? Well, we don't have to use anything special to find out the value of this v. Once you get the value of this v, rest of the things can be easily done. Now, the process of solving this question is exactly same as what we have been doing till now. You'll have to make three equations. First equation along tangential direction, second equation along radial direction, third equation in the perpendicular direction where this motion is happening. In that equation, now we are not going to get anything. And then you have to make the equation for work energy theorem. Now, here, if I resolve this normal reaction, N, normal reaction N is in the radial direction. You don't need to resolve it. But when you look at this weight mg is vertically downwards. Now this weight mg has to be resolved, and it has to be resolved in two directions. The first direction is like this, the blue direction, and the second direction is like this, the green direction. Now, how do we resolve this? As you can see, this angle is theta. Let me take this b out. Oops. Take this b out, everything goes away. Okay. So, this angle is theta. So, this angle also becomes my theta, alternate angles. Mg is downwards. So, this component becomes my mg cos theta component. And the green component becomes mg sin theta component. And now I want you to remember this. It's very easy to understand this, but I want you to remember this always and never to forget. So, if I make the first equation is in the tangential direction. We always make the first equation in the tangential direction, Ft. Now, there's only one force in the tangential direction, and this one force in the tangential direction is mg sin theta. Do we understand this? Can I have some raised hand that we understand this, that there is one force now in the tangential direction, and that force is mg sin theta? From here, you can equate this force to m into at. M and m will get cancelled, and the value of your tangential acceleration will be equal to g sin theta. You are not going to be asked this question ever, but you know the answer now. You know the answer now. That is the answer for your tangential acceleration. Now we make the second equation, the blue equation in the radial direction, F centripetal, which is equal to mv squared by r. mv squared by r, that must be equal to the net force towards the center. Now when I have to find the net force towards the center, what I see is one force is mg cos theta, which is towards the center. One force is normal reaction, which is outwards. So one force is inwards, the other force is outwards. So you have to find the net force inverse. So how do you find the net force inverse? You will have to subtract from the inward force mg cos theta. You have to subtract the normal reaction n. Do we understand this? This is how you make the equation for the centripetal direction. The third equation would be in the f perpendicular direction. There is no force here in the f perpendicular direction, and hence you cannot make any equation. As you can understand, there is a difference between how these equations are looking in the vertical circle, whereas how these equations were looking in the horizontal circle. Do we understand this? Can I have some reason that we understand this? Okay, great. I will give you a minute to note down these three equations, and then we will move ahead. I hope you have noted down this equation, everyone. Can I have some reason that we understand this? Great. These are the three equations. I've got the value of tangential acceleration. The second equation is an equation between velocity v, which I am marking in green, and normal reaction n, which I am marking in pink. Now this n and v, normal reaction n and velocity v, both are unknowns. The first equation only gives me the value of at, but in the second equation, at doesn't come. At doesn't come. We have two unknowns and we have one equation. Problem. Obviously, one equation cannot be solved for two unknowns. Therefore, this equation, this problem remains unsolved. I can't solve it any further. What do I do now? Who helps me? Lord Krishna is not going to come. Who will help me now? I have made all that I had. I could have made three equations. I have done that. What do I do now? Sit, relax, pray to God that He will come and help me out? Or do I have anything else left in my armory that I can bring forward? Oh, this is what I'm left with. And probably that is going to give me the answer. Is there anything left with me? Yes, there is a very big weapon left with me right now, which I studied in work for energy. And that is equation number 4. Lock me, law of conservation of mechanical energy. I will apply lock me from point A to point B. I will apply lock me from point A to point B. Taking some reference level, I will find out the potential energy at point B, kinetic energy at point B. Taking some reference level, I will find out potential energy at point A, kinetic energy at point A. Kinetic energy at point A is 0. I will find out the potential energy at point A. I will find out the potential energy at point B. I will find out the kinetic energy at point B. I will rewrite the kinetic energy at point A 0. And from there, I will get one equation. And that equation will give me the velocity. Now, I'm not going to make that equation because so no use for you. I will just give you the value of velocity that we get from that equation, and the velocity v that we get from that equation is root over 2 times GR into 1 minus cos theta. Remember, bacha, for your NEET, you don't need to make this equation. You just need to remember the value that you get from that equation. That is all that is required from you guys. Do we understand this? Can I have some raised hand that we understand this, sir? Do we understand this? Yes. So this is the value of the velocity v that you had to find out. That is the most important thing that you must remember. And it does not come from equation number 1. It does not come from equation number 2. It does not come from equation number 3. It comes from equation number 4, which is law of conservation of mechanical energy. If theta is 30 degrees, you just put cos of 30. If theta is 60 degrees, may not be the case. If theta is 60 degrees, you just put cos 60 and you get the value. Now, once you get the value of v, once you get the value of v, you put this value of v in this equation and you will get the value of n. You put the value of v in this equation and you will get the value of n from here. That is your homework task. You will have to do it on your own and remember the formula that you get for n. Can you do this for me? Put the value of v from here in equation number 2, get the formula for n, derive that formula for n on your own, just put it plus minus multiply divide and you will get the answer for n. And remember that answer for n. If you don't remember that answer for n, you should always remember the value of this v. Once you know the value of this v, you know how to make the equations. You should be able to find out the value of n. I am not giving you so many formulas because then you will get confused. The only and the most important formula here is finding out the value of v, and that is the formula that I am giving you. Now, I'm not giving you the formula for n. If you want, I have given you the equation for n. Put the value of v in that equation and you will get the formula for n. Do we understand this? Can I have some reason that we understand this, sir? Do we understand this or not? Yes. The third thing that we had to find out is the value of your centripetal acceleration, which I am now marking in pink. Again, I am not going to find out this. This is again going to be a task for you to find out the value of this centripetal acceleration. Everyone knows what you got to do to find out the value of this centripetal acceleration. I have given you the formula for v. You just have to find out AC, and AC is nothing but v square by r. You know the value of v, square it. You know the value of v, square it, divided by r, and you have the formula for centripetal acceleration. So everything comes from this equation. If you remember this equation and the other 3 equations you know how to make, you should be able to derive the formula then and there itself. If you don't want to derive the formula there, I'm not going to do it for you because I think too many formulas will get you confused. I'm only giving you one formula, which I think is the most important one. I've given you how to find out equations. If you want your formulae, you can get the value of your formulae, get the value of your n, and keep it in your head. I leave that job to you. Leave 2 or 3 lines so that you can derive the formula for n and you can remember it. I'll give you a minute to note down everything that I've said. If there's anything that is troubling you, please let me know. I hope everyone has noted this down. Yes or no? Shall I move ahead? Okay, now we'll be solving a question on the similar lines. A bead of mass m, is at rest at the top of a cylinder of radius r. It is given a slight push. So what will happen if it is given a slight push? It will move down. When it makes an angle of 37 degrees with the vertical. So it is now making an angle of 37 degrees. It has fallen down. It is making an angle of 37 degrees with the vertical. Find number 1, the velocity v. Number 2, the normal reaction force. Number 3, tangential acceleration. Number 4, centripetal acceleration. I have covered all the questions here. This is just for you to understand and remember all these formulae. Your time to solve this question and to remember these formulae starts now. I will be back in a minute, and I hope that you have the answers by that time. A minute, 2 minutes. Okay then, let us solve this question. How are you going to solve this question? Everything is given. Oops, wrong color. Everything is given. The angle that it makes is 37. You have to remember the value of cos of 37 and sine of 37. I hope everyone remembers this. Cos of 37 degrees is 4 by 5 and sine of 37 3 by 5. Okay? Do you all understand this? Do you all understand this? Okay, you just need to put the values and get the answer. The first one is to find out the value of V. V is under root of 2 times G R into 1 minus cos theta. We are not going to derive this. We already know the formula and you have to remember this formula. So it is nothing but under root of 2 times G R 1 minus cos of 37, 1 minus 4 by 5. I can now solve it. 1 minus 4 by 5 is 1 by 5. So the answer is root over 2 by 5 GR. Do we understand this? Yes or no? Can I have some raise hand that we understand this? The first answer is V is equal to root over 2 by 5 GR. That is the first answer that we were looking at. Let us move ahead, and since we know V, I can now move ahead and find the value of centripetal acceleration. My centripetal acceleration is V squared by R. Every one of us knows this. Square the value of V divided by R, and we'll get the value of centripetal acceleration. I hope you can do this. It's as simple as it gets, and it will be equal to 2 by 5 times of G. Do we understand this? Can I have some raised hand that we understand this, sir? It is very simple, sir. Once I get the value of V, things are very simple. Yes or no? The value of centripetal acceleration is V square by R. V ka square divided by r. Now let us go on to the value of tangential acceleration. We also know the formula for tangential acceleration. This is equal to g times of sine theta. G is g, sine theta is 3 by 5. So the answer is 3 by 5 times g. So once you understand which case is belongs and you remember simple things, you should be able to calculate the value of the unknown quantities. Now, to find out the value of n, remember equation number 2, m into ac, m into ac or v square by r. Oops. M into AC, which is equal to m into v square by r. That will be equal to mg cos theta minus n. From here, you can calculate the value of n, which I will be doing it right now for you guys. So, m into v square by r, m into AC. AC is 2 by 5g. So, 2 by 5g. So, 2 by 5 mg. M into v square by r or m into AC becomes 2 by 5 mg. That will be equal to mg into cos theta. Cos theta. Cos theta is 4 by 5. So 4 by 5 mg minus n. From here, I can get the value of n, and the value of n will be coming as 2 by 5 mg. As you can see, so far, and so good. I just put the value of AC. AC is 2 by 5 times G in this equation. So this becomes 2 by 5 mg. I just put the value of wrong color. I just put the value of cos theta. Cos theta is 4 by 5. And I get this equation. From here, I can get the value of n, and n is 2 by 5 times mg. Do we understand this, everyone? Well, you can note this down while the class is over. I'll give you time. I'll keep the screen on. You can note this thing down. Remember the three formulae. We have done one case of motion in vertical circle. In the next class, we will be dealing with more cases of motion in a vertical circle. I hope you have enjoyed this class. Till next time, till the next class, the class is dismissed. I hope you stay happy and healthy and keep studying hard. I'll meet you in the next class on Thursday. Take care. Have a nice day.